All right, let's solve some systems using matrices. Let's see, using Gaussian elimination with backward substitution. Show, work, and notate your row operations. Okay, so basically what we're going to do is we're going to take the system and take everything away from it except the numbers, knowing that we're lined up with our x's and our y's and our constants. And then we're going to start manipulating the rows, and our goal is to end up with a matrix, if it's a 2 by 2, with a 1 and a 0 and a 1 here, and then some number here. So that's our goal on a 2 by 2. On a 3 or our 2 variable, and then a 3 variable, you just add another row to it. Okay, so I start out by making sure that everything is lined up in my equation. My x's, my y's, my constants. So then I put it into a matrix. So I have 1, 3, -7, -5, 4, -22. Okay, I already have a 1 in this position, so I'm done with this row. I'm not going to mess with it anymore other than I'm going to use it to eliminate some things from the next one. Okay, so I need to get a 0 here. So what I can do, I can only do that by adding and subtracting. So if this is -5, I want to turn this into a 5. So I'm going to take 5 times R1 plus R2 and put that into R2. Remembering, of course, that this is our R1 and our R2, and this is our X, this is our Y, and this is our constant. Okay, so if I take 5R1 plus R2, 5R1 is going to be 5 times 1, 3, -7, which becomes 5, 15, -35. And then to that I add row 2, which is -5, 4, -22. And when I do that, I get 0, 19, and -57. So my new matrix becomes 1, 3, -7, and then this row becomes 0, 19, -57. Okay, so I'm going to start up here and get the 0 below it. Now I want to turn this into a 1. Well, all I have to do in order to do that is take R2, divide it by 19, and put that into R2. So if I have 0 divided by 19, 19 divided by 19, and -57 divided by 19, that becomes 0, 1, and -3. So my first row remains the same, 0, 3, -7. But now my second row becomes 0, 1, -3. Okay, of course, remembering then, this is why it's important to remember that these are coefficients of x's, these are y's, and these are the constants. So this row tells me that 1y is equal to -3, or just y is equal to -3. Now, this is where backward substitution comes in. If I know y is -3, oops, and that's a 1, I'm sorry. If I know y is -3, then I can plug that into this row. And I get 1x plus 3y is equal to -7, which means 1x plus 3 times -3 is equal to -7. So x minus 9 equals -7, so x is equal to 2. So my solution, written as an ordered pair, becomes 2, -3. Okay, same thing on the next one. All right, I'm going to take my matrix and turn it into, or take my equation, turn it into a matrix. 3, -2, 5, -1, 8, -9. R2, X, Y, constant. See, I've got almost a 1 here, so I think what I can do is just flip-flop the rows. So in my first move, I am going to take R1 and R2 and exchange them. So that's going to be -1, 8, -9, 3, -2, 5. Okay. So let's see. In my top row here, what I'm going to have to do is I want that as a positive one. So I'm just going to take -1 R1 into R1. And I don't think that's going to be a big deal. That means I'm just going to change the sign on everything. So this becomes 1, -8, 9, and 3, -2, 5. Okay, so I'm done with row 1. That will be the same in all of the matrices down the line. All right, so I want to get rid of this 3. So let's see what I can do with that. If I multiply this times -3 and add it to 3, then I'm good. So what I'm going to do here is I'm going to take -3 R1 plus R3 and put that, R2, excuse me, and put that into R2. So -3 times 1, -8, 9 gives me -3, 24, -27. I'm going to add that to 3, -2, 5, and I get 0, 22, -22. Okay, so my next matrix is 1, -8, 9, 3, oops, and then here I'm going to put in 0, 22, -22. Okay, so I've got the 1, 0. I need to turn this into a 1. So I can do that. So I'm just going to take R2 divided by 22 and put that into R2. So that gives me 0 over 22, 22 over 22, -22 over 22. So I have 1, -8, 9, and then I have 0, 1, -1. Okay, so what happens from here is this tells me that y is equal to -1. So I will combine that with my first row here. So that gives me 1x minus 8y is equal to 9. So x minus 8 times -1 is equal to 9. So that gives me x plus 8. Oops, I'm running off the paper. Equals 9. So that tells me that x equals 1. So written as an ordered pair, this becomes 1, negative 1. All right, when I have a three variable, three variable, equation system, it's basically the same thing. Okay, now to save space, here's what I'm going to go ahead and write this as a matrix over here. So now I have to have a column for an x, for a y, for a z, and then a constant. And I have to have row 1, row 2, and row 3. So row 1 gives us 1, 3, negative 2, 4. I don't have any x's here, so that's a 0, negative 2, 4, and negative 6. And here I have negative 3, negative 9, 8, and 10. Okay, so R1 already has the 1 here, so I don't have to do anything with it. So when my next iteration, I'm going to have 1, 3, negative 2, 4 in my first row. Okay. Now, row 2, well, I want a 1 here, so I can actually, well, let's do it one step at a time. Let's get the 0 here first. So we'll leave this one alone for a minute. So I'm going to work with row 3. 0, negative 2, 4, negative 6. And I want to do something with this row. So what I want to do is I need a 0 here. So if I take 3R1 plus R3 and put that into R3, then it'll give me what I want. So 3R1 becomes 3, 9, negative 6, 12, and then negative 3, negative 9, 8, and 10. So that gives me 0, 0, oh, this is nice, 2, and 22. So 0, 0, 2, and 22. So this is exactly like I wanted as well. So now the only thing I need to do here is I need a 1 here. So from here, I know this is going to remain the same. This is going to remain the same. But what I need is I'm just going to take R2 divided by negative 2 and put that into R2. Okay, so 0 divided by negative 2 is 0. Negative 2 divided by negative 2 is 1. 4 divided by negative 2 is negative 2. And finally, negative 6 divided by negative 2 is 3. Okay, then finally, I am going to have to, in my very last iteration of this, I need this a 1. So 1, 3, negative 2, 4. And then this is 0, 1, negative 2, 3. And then from here, I'm going to take R3 divided by 2 into R3. So that's going to give me 0, 0, 1, 11. Okay, so what does this tell me? This tells me at the bottom here that Z is equal to 11. I'm going to take that and move it up a row and find y. So that's going to give me y minus 2 times 11 is equal to 3. So y minus 22 is equal to 3. So that tells me that y is 25. Then I'm going to take my z and my y, and that's going to tell me that x plus 3 times y minus 2 times z is equal to 4. So that gives me x plus 75 minus 22 is 4. X plus 53 is equal to 4, which tells me that x is negative 49. So then written as an ordered triple, my x is negative 49, y is 25, and z is 11. Okay, same thing here. Everything's all lined up nice and pretty, so I'm going to put it into its matrix, and I'm going to try to write smaller on this one so I have enough room. 1, 3, negative 7, negative 1, 2, negative 4, 1, 3, negative 2, 4, negative 2, 10. Okay, so when I'm going down here, I know my first row is good. 1, 3, negative 7, negative 1. Okay, well, just by looking at this, I can do a couple of things. If I add these together, I get a 0 and a 0, which is what I want. And so that can easily go into R3. So I am going to take R2 plus R3 and put it into R3. So that's going to give me 0, 0, negative 1, and 13 when I just add these two rows together. And just to make sure that we do this one step at a time, then this is 2, negative 4, 1, 3. All right, so I've got row 1 and row 3 almost taken care of. So this gives me 1, 3, negative 7, negative 1. And I'm going to go ahead at one fell swoop here and say, all right, well, I'm going to take R3 divided by negative 1 into R3. So that's going to give me 0, 0, 1, negative 13. Now for R2, if I multiply R1 times negative 2 plus R2 into R2, that should take care of it. So that's going to give me negative 2, negative 6, 14, and 2, plus 2, negative 4, 1, and 3. So that gives me 0, negative 10, 15, and 5. So 0, negative 10, 15, and 5. Okay, so the only problem here now is for my R2, R1 and R3 are okay. So 1, 3, -7, -1, 0, 0, 1, -13. But I got to do something with R2. So I'm just going to take R2 divided by -10 and put it into R2. So that's 0, 1. 15 divided by -10 is -1.5. 5 divided by -10 is -0.5. Okay, and I'm good to go. All right, so this tells me that y is equal to -13. Okay, so let's put that in here. So this tells, I'm sorry, that's the z, excuse me. Okay. Then this tells me that y minus 1.5 times z is equal to -0.5. So that gives me y plus 19.5 is equal to -0.5. So that tells me that y is equal to -20. So now I'm going to take both of these and put them into my top equation to find x. So that gives me x plus 3 times y minus 7 times z is equal to -1. So that's x minus 60 plus 91 is equal to -1. So x plus 31 is equal to -1. So x is equal to -32. So my solutions are, my x is -32, y is -20, and z is -13.